Radioisotopes are isotopes of an element that give off radiation. The atoms of the element are radioactive due to the imbalance of protons and neutrons within the nucleus of the atom, making it unstable. One common radioisotope is uranium-235. It has an atomic number of 235 because it contains 92 protons and 143 neutrons, thus giving it an atomic number of 235. Uranium-235 produces alpha radiation, which is the least penetrative type of radiation. It can be stopped by a sheet of paper or human skin, and is simply a helium nucleus that is positively charged. Uranium-235 has a half-life of 703.8 million years, meaning that it takes that long for half the atoms in a pure sample to decay into another element. The half-life of uranium-235 is extremely long compared to other radioisotopes, which means that when it is not used, it must be sealed up and buried for thousands of years to allow the radioactivity to decay. Uranium is used in industry for a variety of different uses, including lighting fixtures, photographic chemicals, phosphate fertilizers, ballast for helicopters and planes, which acts as a counterweight on the wings, parts of bullets, missiles, and nuclear weapons. But it has a main use as fuel for nuclear power plants and naval reactors. Naval reactors refer to the US Navy's $1 billion nuclear propulsion program, which essentially is a program working on running naval vessels on nuclear energy. The advantages of uranium-235 is that by using U-235 to power nuclear power plants, carbon dioxide emissions are minimal, meaning that it leaves a smaller carbon footprint than coal. Nuclear energy is very reliable and does not use as much of the actual product. For example, 1 kilogram of uranium-235 produces the same amount of energy as 1,500 tons of coal does. Therefore, the US Navy's nuclear propulsion program allows the vessels to travel longer distances with uranium-235 as opposed to coal. There are also many disadvantages. Since U-235 only equates with 0.72% of all natural uranium, there is a limited supply. However, due to the small amount needed, it is not a very large issue. It also creates a lot of radioactive waste, which in large amounts is toxic to humans and the environment. In some cases, there is no way of avoiding U-235 getting into our bodies, such as it being in the air or swallowed. There aren't very many implications when this happens, and will either be excreted from the body or ingested into the bloodstream. If U-235 is in the bloodstream, it will be removed by the kidneys and excreted in a couple of days. To keep people and the environment clean, a lot of money is spent on safety. The advantages weigh out the disadvantages. Even though uranium-235 is rare, not very much of it is needed. Safety is of an issue, but as it only emits alpha particles, it is not of great concern. Using uranium to power naval vessels and power plants is more environmentally friendly, as it creates a smaller carbon footprint than other non-renewable energy sources.